Hello guys. Now today we will see this question from orthographic projection, drawing sheet number 4, question number 1. See, in this question a elevation sectional elevation along section AA is asked. Then plan and left hand side view. So this is a sectional orthographic question. For sectional orthographic, the sectional we have to draw. In answer we have to draw first sectional front view, top view, and the plan means top view, elevation front view means elevation, and left hand side view. So the dimensions for this are, so length here is, see, this distance, that is the center of cylinder, from center of cylinder to center of this vertical cylinder, this distance is 110 mm. Okay, so length is, total length is, this horizontal cylinder has a outer radius is 20. So from this center, this extreme left point is at 20 mm. Then from this outer cylinder, outer circle has a radius of 60 diameter. It has a 60 diameter, so it has a radius of 30. So total length horizontally, its total length is 20 plus 110 plus 30, means total length is 160 mm. Then width is equal to, width means so width, that is the maximum width is, this cylinder has a diameter 60, then from center point of the cylinder, an extreme front point is at 64 mm. So 64 plus radius is 30, 64 plus 30, width is equal to 64 plus 30, that is 94, and total height is here given 60 from this point to this point. This is the total height. See, check for any complications in diagram. The maximum height is 60. Okay, so now we will draw, now we will take a middle point as per these dimensions. So in question left hand side view is asked. So we will draw left hand side view on right side of front view, and top view will be here. So this is space, this much space is required for front view, 160 by 60 mm, LHSV 94 by 60, and top view 160 by 94. Now we will start to draw orthographic view. From which projection, which view is easier? So generally front view is easier. So this in front view, this cylinder will look like a square or rectangle. See, this cylinder has a 60 diameter, so width is 60 and height is 50 plus 10, 60. Then in front of that, these two rectangles are visible. Then this stiffener is visible, and this circle of cylinder is visible. Then this base plate is visible. Then hidden parts in front view are, so this is a sectional front view along section AA. Section AA means this line. Okay, so if we cut this 3D object into two parts along this plane section AA, then the back this backward part is visible, and during cutting, if any material is cut, then we will show this material by hatching. Hatching means a line of 45-degree angle and 2 mm distance. Line has a 2 mm spacing and has an angle of 45 degree to the horizontal line. So this is a orthographic view. We have started from here. So from this extreme right base point, lower point, the height is 60. So this is 60. Then this diameter is 60. Then from this point, that is extreme right point, the center of this circle is at distance of 30 plus 110, that is at 14 mm distance, 14 centimeter distance. So from this point we have taken 140 mm. Then the center located at a distance of 2 mm, 2 centimeter above the baseline. So then 2 mm is taken here, and this is center. Now semicircle of 20 radius is drawn, and then diameter of 25 circle is drawn. Then along section A, if we cut this plane along section A, then excluding this stiffener part, excluding this part, we will mark all part by hatching. So this is a sectional front view. Only part that is being cut is hatched, and hatching means inclined line of 45-degree angle, and the spacing between two lines is 2 mm, approximately 2 mm. And in this circle, this part is stiffener, that is support part between this cylinder, horizontal and vertical cylinder. So only stiffener part is excluded during hatching. Then top view, for top view, 160 by 94 area is selected, and then the projection of this axis, centroidal axis, is taken. Then at this axis 3 mm is taken, and from this center point 2 circles of 40 and 60 diameter is drawn. Then this distance is given 6.4. This distance, that is, this distance is 6.4, 64 mm, and this distance is 10 mm. So this also drawn. Then projection of cylinders left and right side is taken. Now this horizontal cylinder has a length 40 mm from this axis, 2 mm from 2 mm backward and 2 mm in front of this centroidal axis. Now at 2 mm from this point, just parallel line to the axis is drawn from this point to this point, projection of this point to this point, and also this. Then in question, see here, from this point a tangential, from this point a tangent to this cylinder is drawn up to this point. So from this point to this point, just draw line, draw inclined line, and also from here. So this part is not visible in question. So considering similar, that is mirror image, we will connect this point and a line tangential to the outer circle. So this is a top view. Now from this center point, draw a center line, line dot, Then this is a hidden, so draw dash line. Here also draw dash line. So this is a complete top view. Only stiffener part is remaining. So for stiffener part, as tangential point, this tangent to the circle is here. So take projection of this point on center line. Then the stiffener has a width of 10 mm. This support part has a width of 10 mm. So from this center point, take 5 mm from both sides and draw a line from the circumference of this outer circle up to this line. As this plane, this fillet upper plane is tangential to the cylinder, so draw this symbol for tangential. So this is a top view. Now we will draw a front view. Before that, remove this part. Now side view is drawn by taking projection of front view and top view on side view area. So take projection of important points or horizontal lines from front view in left hand side view, and projections of important points of top view and horizontal lines on LHSV through this 45-degree inclined line. So this line is for reference. As this line angle is 45 degree, take this angle with the help of protractor. As this distance is 1 centimeter and also this distance is 1 centimeter, so from this point, this length, this angle of this line should also be equal to 45 degree. During taking projection, make sure that projection lines are parallel to this horizontal axis. This is a projection, horizontal projection of top view on this line. These are the points. Then take vertical projection of this point in side view area. First take the take this scale parallel to the vertical axis and draw up to side view area. Then also take projection of front view's horizontal line on left hand side view area. During taking projection of center of circle, take center line, draw center line. Now this is a area of left hand side view. This is starting point of left hand side view. Now the left hand side view direction is this. This is left hand side view direction. So first we will see this rectangle of cylinder. Cylinder will be shown as a rectangle. In front we will see this rectangle. Then behind that we can see this square, that is this cylinder will be seen here as a square of 60 by 60, and then this part 10 by 60 rectangle and this 24 by 60 rectangle with these ovals, this shape, rectangle and semicircle on both sides. So this is a front cylinder, and in this cylinder there is a cylindrical hole of 25 mm diameter. Then we will take the projection of these inner cylinders, upper point and lower point, and we will draw these points as a dashed line, dot line. Then Then this outer cylinder, vertical outer cylinder, is from at a 10 mm distance, 10 mm height. So this is a 10 mm height. So these base plates are like this. These are the base plates. This is outer cylinder. This is backward cylinder. Then this is front cylinder. So this shape has a from top surface, this center has 2 centimeter, that is 20 mm. Here it is a semicircle of 5 radius, 5 mm radius. Then the distance between two center are is at 20 mm. Then from this point 5 radius, from this point 5 mm radius, and then this rectangle part, and with this shape. This is the outer rectangle. See here. This is the outer rectangle with this shape. Then this is this rectangle, and this is outer cylinder, vertical cylinder, and this is horizontal cylinder. This is stiffener part. So this is a diagram with dimension. Show, suppose in question 15 dimensions are given, then distribute equal dimensions among front view, top view, and side view.